You know, for all these years, we've been looking up at the stars, launching rockets, making plans for Mars. We thought we were playing in the big leagues, that we were on the verge of some great discovery. We were wrong. We were just playing in the sandbox. In August of 25, NASA published a report, dry, scientific, full of numbers. But between the lines, it spelled out one word: impossible. Their Sphere-X telescope, which was just supposed to be cataloging galaxies, stumbled upon a visitor. They named it 3I Atlas. And at first, everyone just yawned. Sure, another interstellar object. We'd already had Oumuamua, Comet Borisov. We thought we knew the rules. Comets are dirty snowballs of water and gas. Asteroids are rocks. Simple, understandable, fits the models. But 3I Atlas, it's something else. It breaks the fundamental rules. Imagine finding an animal on Earth that doesn't breathe oxygen, but pure argon. And it isn't made of protein, but of something that shouldn't even exist. That's what we saw. Every comet we've ever studied is a kind of cosmic soup. Water, carbon monoxide, carbon dioxide, leftovers from the creation of the universe. But this thing is breathing out only one thing: pure, distilled CO2. Not a drop of water, nothing extra. It's unnatural. It's like finding a perfectly polished titanium cube in the middle of a wild forest. Nature doesn't make things like that. It's chaotic, messy, diverse. But this thing is a clean, deliberate anomaly. And this is where it gets really interesting. The size. Oumuamua was the size of a skyscraper. Comet Borisov was the size of a small neighborhood. But 3I Atlas is up to 46 kilometers in diameter. That's not a rock. It's not a comet. It's a goddamn small moon. The odds of the very first giant interstellar object we find being this strange are statistically zero. It's like winning the lottery 1 billion times in a row. The math is screaming that something is wrong here. So we've got two options, and they're both terrifying. First, our understanding of the universe is complete garbage. All our theories about how star systems form can be thrown right in the trash. We know nothing. The second option is a lot more interesting. What if this isn't a natural object? What if it's a probe, a ship, or just a message that says, "We are here, and our technology begins where your physics ends"? People are scared to look inside this Pandora's box. But I say we don't just open it. We need to crack it wide open. Because this isn't just an astronomical discovery. This might be the most important signal in all of human history. And we have an absolute duty to figure out who sent it. Avi Loeb, the Harvard astrophysicist known for backing theories of alien tech in cases like Oumuamua, is once again in the spotlight. According to Loeb, the trajectory and properties of 3I Atlas might not be a coincidence. The object is moving along the ecliptic plane, the very same one our planets orbit on. That's a 1 in 500 coincidence. And coincidences have their limits. The lack of a traditional comet tail, combined with the selective outgassing of CO2, raises another suspicion. Is it possible that 3I Atlas has a modified surface layer hiding its true nature? Or is it just a piece of interstellar rock with a composition so rare that we've never seen anything like it in billions of years of looking? And then there's the most thrilling problem: the glow. Images from Sphere-X and Hubble show that the glow around 3I Atlas isn't like a normal comet's. Instead of dust particles reflecting sunlight, part of this glow seems to be coming directly from the core itself. This points to two equally mind-bending ideas. Either the object is so massive that it dominates the light spectrum on its own, or there's some kind of process happening on its surface that we've never seen before. In the middle of this flood of data, a philosophical dilemma emerges. How willing are we to accept the existence of something we can't explain? Science is built on finding patterns, but right now, 3I Atlas is the definition of a wild card. Every new piece of data published raises more questions than answers. If it has no water, how did it survive the deep freeze of interstellar space? If it's so massive, why haven't we spotted dozens of similar objects by now? And if its trajectory really was programmed, who or what was the programmer? This uncertainty is creating tension not just in the scientific community, but in the public consciousness. Every new update about 3I Atlas instantly hits discussion forums, enthusiast groups, and newspaper headlines. It's getting hard to tell if this story belongs to science or science fiction. The discomfort only grows because this object is forcing us to cross that fine line between searching for natural laws and considering the possibility of cosmic intent. The most unsettling part is that this is all unfolding right in front of our eyes. 3I Atlas isn't a distant memory like the WOW signal from 1977 or a fleeting glimpse like Oumuamua. This is an ongoing event, being watched in real time, with data being collected that just doesn't add up. And, like in any good space story, the closer we look, the less we understand whether we're dealing with a freak comet or the first real proof that we are not alone. The next level of this mystery lies beyond its chemistry and size. Its trajectory and cosmic coincidences might be hiding signals that could reveal something far bigger, and possibly far more disturbing. When space challenges our reality, the shock from 3I Atlas isn't just limited to equations and charts and scientific papers. This discovery is already starting to leak into our everyday lives, affecting public debate, our ideas about the universe, and even our thoughts on the fragility of human civilization. When an object 40 kilometers wide cuts through our solar system, leaking only carbon dioxide and showing none of the classic signs of a comet, its impact becomes more than just technical. It becomes psychological and cultural. Modern science has always taught us that space is predictable and follows unbreakable laws. Celestial mechanics are so precise we can predict eclipses centuries from now, calculate orbits with minimal error, and plan landings on other planets years in advance. But 3I Atlas shatters that confidence. It's the embodiment of the unexpected, a reminder that the universe is still full of things that don't fit into our neat little boxes. Think about how our civilization is built. Our economy, society, and even our religions are based on the idea of order, repetition, and reliable patterns. When space throws a celestial body at us that defies those expectations, the effect ripples outward. It starts in labs and universities, but soon it reaches social media debates, conversations at the bar, and even our deepest fears. After all, if we can't fully understand an object flying through our cosmic backyard, how well do we really know the universe at all? In the world of applied science, the consequences are unavoidable. Space missions are built on predictability. Probes, telescopes, and satellites are designed based on centuries of consistent observations. Now, imagine you're an engineer tasked with interpreting the data from 3I Atlas. How do you plan to intercept an object that doesn't behave like it's supposed to? How do you build sensors to detect molecules that were, until now, considered universal for comets? This dilemma pops up in less obvious places, too. Planetologists studying Earth's formation will have to rethink how organic molecules got to our planet. For decades, the theory was that comets played a huge role in delivering water and carbon compounds. If 3I Atlas is a representative example of interstellar objects, it changes the entire picture. An alien visitor that brings no water, only CO2, reopens the debate about how life on Earth really began. This discomfort isn't new. In 2017, after the discovery of Oumuamua, the world's media was split between the idea of an elongated asteroid and Avi Loeb's suggestion that it could be an artificial probe. Back then, many dismissed the idea as speculation, but the cultural footprint remained. Newspapers, podcasts, books, and even TV shows normalized the idea that we might be seeing interstellar artifacts. But 3I Atlas is different. It's not just hinting at anomalies, it's confirming them with solid, verified data. To better understand this impact, here's a simple analogy. Imagine you live in a city where you see the same birds every day. Sparrows, pigeons, swallows. One day, a flying creature appears that doesn't flap its wings, makes no sound, and glows from the inside. You could write it off as just a weird bird, but the feeling of unease lingers. You can't explain the anomaly with the usual rules. Three-Eye Atlas is that cosmic bird that has broken the familiar order of things. When science runs into an object that challenges our understanding, the effect doesn't stay within the walls of a lab. It affects how people see their place in the universe. For some, it becomes a source of wonder. Some feel a sense of awe, realizing they're alive in an era when mysteries of this scale can be studied in real time. For others, it's a source of anxiety, a feeling of vulnerability in the face of forces beyond our control. This dual effect is already showing up in specific behaviors. Interest in astronomy discussion groups on Reddit, specialized forums, and YouTube channels has skyrocketed. Terms like Three-Eye Atlas Anomaly or CO2-only comet have become trending topics in online science communities. At the same time, conspiracy theories are multiplying, questioning NASA's silence on the data from the James Webb Telescope, which still hasn't been published. When official knowledge falters, the collective imagination fills the void. This is the moment Three-Eye Atlas stops being just a scientific mystery and becomes a cultural catalyst. To make this discussion more relatable, think about how we react to surprises outside of science. Imagine you've been buying coffee from the same shop for years, and you always get the same taste, the same aroma. One day, with no explanation, the coffee has a metallic taste. You don't die, you don't get sick, but something is clearly wrong. You ask the barista, but they can't explain it. That's the exact feeling of discomfort scientists are experiencing with Three-Eye Atlas. The numbers are there, the instruments worked perfectly, but the result makes no sense within the cosmic menu we know. This feeling that the universe is serving us something unexpected undermines our faith in our accumulated knowledge. It's as if space is reminding us that we're still students, sailing on a vast ocean without a reliable map. This is where the story needs to evolve with you, the audience, because Three-Eye Atlas isn't just a topic for expert astrophysicists. It speaks to all of us, to how we deal with the unknown. When science finds something that doesn't fit the mold, we have two choices: ignore the anomaly and move on, or face the discomfort head-on and admit we need to build new models. This dilemma is a direct reflection of our daily lives. How often do we ignore the strange signs in our own paths, preferring to believe that everything is under control? 3. Atlas is a magnified mirror of this dynamic. The discomfort it causes is the same one we feel when our routine is broken, when a pattern shatters, when something forces us to rethink our beliefs. That's why it's so important to follow this story. Because every new piece of data published isn't just a scientific fact, it's an invitation to rethink our own way of thinking, our beliefs, and our plans for the future. So before we go any further, here's a direct request. If you feel that this reflection has value, that it sparks your curiosity and expands your horizons, subscribe to the channel and show your support. This community grows as more and more people decide to look into space without fear. And simple actions, like hitting the like button or sharing this, help keep the search alive for answers we don't have yet. While we're talking about this, Three-Eye Atlas continues its journey through our solar system, leaving behind a trail of questions we can't answer. The most frustrating thing is realizing that despite all our advanced technology, we still don't know if we've encountered a strange natural object or something deliberately placed in our path. But the most alarming part is still to come. The origin of Three-Eye Atlas may be linked to a cosmic coincidence that reignites one of the greatest mysteries in the history of astronomy. And that's what we'll explore next. Science is in conflict with the unknown. As more data on Three-Eye Atlas piles up, so does the anxiety among scientists. This is no longer just a one-off astronomical curiosity. We're facing a celestial body whose composition and behavior threaten the very foundations we rely on to understand the origin and dynamics of interstellar objects. NASA itself admitted in preliminary reports that the results from SphereX don't fit any previously observed patterns. The most critical aspect is the spectrographic analysis. Ever since we started using spectroscopy to study deep space, we've been able to identify molecules billions of kilometers away. Every substance has a unique signature of light absorption and emission, a kind of cosmic fingerprint. In the case of 3I Atlas, that fingerprint is terrifyingly simple, exclusively carbon dioxide. No stable signs of water, no spectral lines for carbon monoxide. It's as if the entire object has been reduced to a single component, ignoring the chemical complexity of the comets we know. This discovery immediately sparked debate. Avi Loeb from Harvard stated that the lack of chemical diversity could be evidence of a radically different formation process, unlike anything from our own system. Other, more conservative scientists suggest that maybe the instruments just haven't been able to detect deeper layers of the object, where other molecules might be hiding. How can a body tens of kilometers in diameter cross the sublimation zone of our solar system, release only one gas, and show no other signs? Some researchers have drawn parallels with Comet C2016R2, Pan-STARRS, which unexpectedly showed strong emissions of carbon monoxide and nitrogen with low water content. However, even there, chemical diversity was still present. 3I Atlas, on the other hand, seems to be a monolith. Astrophysicist Martin Gardner from the Goddard Space Flight Center stressed in a recent interview that the absence of H2O is extremely unusual for an object at this distance from the Sun, which only deepens the anomaly. This difference creates another problem. If 3I Atlas isn't a typical comet, how should we classify it? Astronomical classification has no category for a massive interstellar object that acts like a comet in some ways, like releasing gas, but lacks the tail and chemical makeup of one. If that's the case, we might be dealing with a new type of celestial body. And if so, how many more like it could be out there, invisible to our sensors? Another technical aspect adds to the mystery. Its size, estimated at up to 46 kilometers in diameter. This is off the charts. For context, the Chicxulub crater on Earth, created by the impact that helped wipe out the dinosaurs, was left by an object about 10 kilometers wide. If 3I Atlas were to hit Earth, it could change the history of life on the planet in a matter of days. Not that its trajectory predicts such an event, but its sheer size is alarming. The statistical problem is even more telling. Models of interstellar object distribution, like the one proposed by Mauro Martin and his colleagues in 2009, indicate that large bodies are extremely rare. In theory, before we ran into a giant like 3I Atlas, we should have detected thousands of smaller objects. Does this mean the models we use to calculate the density of interstellar matter are wrong? Or is something pushing this object in an anomalous way? And here, the question of its trajectory comes up. Unlike Oumuamua, which crossed the solar system at a high angle, 3I Atlas is moving on a path aligned with the ecliptic plane, the same band our planets orbit on. Statistically, this is highly unlikely. For some, it's just a coincidence within the realm of possibility. For others, like Loeb, this coincidence just adds to the list of anomalies that demand a new interpretation. But what interpretation would be acceptable? The artificial origin hypothesis is still considered fringe, though it's gaining traction in more daring discussions. Most scientists prefer to stick with natural explanations, but that doesn't lessen the discomfort. As astronomer Rosica Kakatanova noted at a conference in Bulgaria, sometimes the data forces us to admit that we don't have a model that can explain all the observations. In that case, scientific humility becomes inevitable. Another detail fueling the mystery is its luminosity. Hubble has recorded that the glow around the object is compact, without the diffuse tail typical of comets. This suggests that the radiation isn't just coming from dust reflecting sunlight. Part of the analyzed spectrum shows an emission that seems to come directly from the core. There's no consensus yet on how this is possible. Could it be such a massive body that its own surface dominates the light signal? Or is there some yet unidentified physical process at play? How well do we really know the physics of interstellar bodies? We pride ourselves on sending probes beyond our solar system, yet we still don't have definitive answers about the visitors crossing our cosmic neighborhood. The gap between our advanced technology and our conceptual understanding creates an uncomfortable tension. Comparison with other comets confirms this uniqueness. For example, Comet 29P Schwarzmann-Wachmann 1 shows periodic outbursts of carbon monoxide and dioxide at a distance of 6 astronomical units from the Sun, where water can't yet sublimate. But even in these extreme cases, traces of dust and a mix of different compounds are observed. 3I Atlas, however, seems to insist on being an unprecedented exception. This brings us to a scientific dead end. When the data contradicts the theory, should you adjust the theory or distrust the data? In the case of 3I Atlas, both paths are uncomfortable. The instruments studying it are reliable and are regularly used to map entire galaxies. But the models describing the formation of icy bodies in space have also been tested for decades. Which side will give? There's also the matter of cosmic coincidences. The supposed origin of 3I Atlas aligns with the constellation Sagittarius, near the region where the famous WOW signal was detected in 1977. Although the explanation for that event points to a natural phenomenon, the symbolic connection is hard to ignore. For the general public, it sounds like a mysterious coincidence. For scientists, it's a reminder to evaluate coincidences with statistical rigor without giving in to the temptation of a good story. But it's a fine line. How many coincidences have to happen before the improbable becomes significant? How much anomalous data needs to be collected before the scientific community accepts the idea that maybe, just maybe, it's necessary? Are we facing something that requires a new paradigm? This conflict between prudence and boldness is now on the line. 3I Atlas is a test not just for our telescopes, but for our entire scientific culture. It forces us to choose between the comfort of known explanations and the courage to admit we've encountered the unexpected. And this is where the narrative becomes especially powerful. The intrigue lies not in conspiracy theories, but in the story itself. The complexity of the data. Every spectrum, every orbital calculation, every image received only deepens the mystery rather than solving it. 3I Atlas not only defies classification, it refutes it. And what happens when we add the yet unpublished data from the James Webb Telescope to this puzzle? The silence surrounding that information could be the key to the next shift in perception. Cosmic coincidences and an awkward silence. When we talk about 3I Atlas, we can't ignore a detail that has become the center of countless debates. The trajectory of this object, unlike other interstellar visitors, runs parallel to the ecliptic plane, in the same band where the planets of our solar system orbit. Statistically speaking, the probability of such an alignment being a random occurrence is extremely low, about 1 in 500. For some astronomers, this is just a fluke, but for others, it just adds to the pile of anomalies already found and calls for a bolder interpretation. These debates aren't new. Just think about Oumuamua back in 2017. Its non-gravitational acceleration, a slight change in speed without a convincing explanation, was initially blamed on outgassing. However, later studies, like a 2018 paper in Nature Astronomy, showed that no dust or gas was detected in quantities that could explain that movement. The result was a storm of speculation, much of it simplified by the media, which ultimately left the public with a story of a mysterious asteroid without mentioning the real statistics. The same trend is happening with 3I Atlas. Catchy headlines, but little attention to the fact that, so far, no natural model can fully explain its behavior. And this raises a fundamental question. Why are some scientific reports quickly forgotten or downplayed when they challenge existing paradigms? A clear example is the study of Comet C2016R2, Pan-STARRS, which released large amounts of carbon monoxide and nitrogen, surprising the scientific community. At the time, the headlines were modest, almost always treating it as a chemical oddity. However, that case already showed the limits of our understanding of comet diversity. With 3I Atlas, the anomaly is even deeper. Only carbon dioxide on a massive scale. It's no exaggeration to say that if Pan-STARRS was a footnote, 3I Atlas is a whole page torn out of the cosmic rulebook we thought we knew. And again, We see how popular culture tends to absorb simplified stories. The press loves to talk about signs of life or alien objects, but rarely bothers to discuss the statistical significance of the lack of water or the improbability of the orbital alignment. This disconnect creates a dangerous gap. On one hand, science is accumulating uncomfortable data. On the other, public opinion is being fed trimmed-down, sensationalized versions. The result is a cultural phenomenon where the most contradictory facts get lost in a sea of misinformation. And there's another detail that heightens the tension. NASA's silence on the data collected by the James Webb Telescope on August 6, 2025. More than 2 weeks have passed without an official statement. This wouldn't be the first time complex results are held back until they've undergone a lengthy peer review process. After all, science demands caution, but in practice, such a delay fuels suspicion. In 1977, the famous WOW signal remained shrouded in a fog of vague explanations for years, and the lack of clear answers eventually turned it into a cultural myth. We're seeing the same process with 3I Atlas. The longer we delay clarification, the more room we leave for speculative interpretations. Perhaps the real problem isn't just the object, but our inability to cope with uncertainty. Human behavior in the face of the unknown is very revealing. During the Cold War, any radar blip that was unusual was quickly perceived as a threat. A 1982 study by the RAND Corporation shows that 70% of false alarms in early warning systems were due to interpretation errors. The lesson is clear. When data doesn't fit expectations, we tend to distort or discard it, not out of malice, but as a form of cognitive self-preservation. This is exactly what we're seeing now. Many scientists prefer to fit 3I Atlas into known explanations, even if they're a stretch. Others, more daring, propose new hypotheses. But resistance to the unusual is the norm. After all, admitting that a model is incomplete means accepting that decades of knowledge may need to be rewritten. So the uncomfortable question isn't just what 3I Atlas is, but this. How ready are we to admit that the universe doesn't follow our instruction manual? In this deadlock, the ignored statistics start to carry weight. Avi Loeb, in his calculations, has stressed that the number of interstellar rocks predicted by classic models is 10,000 times smaller than what's needed to justify the existence of an object the size of 3I Atlas floating by. In other words, logically we shouldn't be seeing it. Yet here it is. This discrepancy can't be dismissed as a coincidence without undermining the seriousness of science. At what point do coincidences stop being coincidences? How many times do we have to encounter the incredible before we admit there's some hidden pattern? Popular culture, in turn, rarely touches on these numbers. It prefers spectacle instead. The WOW signal is a good example. In our collective memory, it has become an alien message that was never decoded, The detail that it was likely natural radio emission passing through a hydrogen cloud was ignored because the flashier story stuck better. With 3I Atlas, this trend is already obvious. Headlines talk about an alien asteroid or a sign of life, but almost never mention the exact rate of outgassing. 70 kilograms of CO2 per second, a rate that's impossible to ignore. They also don't mention that the cloud it's creating stretches 350,000 kilometers, which is almost the distance from the Earth to the Moon. These numbers are not just impressive, they underscore the scale of the mystery. By ignoring them, we lose the true scope of the discovery. This selectivity in reporting data is not accidental. It reflects our approach to solving complex problems. We simplify. But there's a risk in that. Every poorly executed simplification is a missed opportunity for collective reflection. And that's exactly what we need right now. After all, if we don't discuss the details, how can we move toward deeper answers? Could it be that the biggest anomaly isn't 3I Atlas itself, but how we choose to see it? Reanalyzing the reports, the comparisons, and the statistics reveals a system of cultural neglect. Space gives us rare data, and we reduce it to media slogans. The most cautious scientists hide the anomalies in footnotes. The media blows them up into sensations. In the middle, the complexity gets lost. 3i Atlas, meanwhile, continues to slice through space, indifferent to our arguments over interpretation. This contrast is a drama in itself. The coldness of the numbers and the heat of popular narratives are incompatible. But it's in this gap between the two extremes that the mystery gains its power. Because it's in what we can't connect, in the data that can't be simplified, in the statistics that can't be resolved, that the universe forces us to look deeper. And this is where the most uncomfortable question arises. What is 3i Atlas revealing to us? Not about space, but about ourselves. The answer requires us to admit that we are not just observing the universe. It is testing us, on trial by the unknown. 3. Atlas, for all its strangeness, is no longer just an object traveling through the solar system. It has become a mirror reflecting our limitations, our fears, and how we approach the unknown. For centuries, humanity has built its worldview on the belief that the cosmos is governed by clear and predictable laws. But every piece of data published by SphereX, every miscalculated probability, every awkward silence from NASA about the James Webb reminds us of something deeper. The order we project onto the universe is a fragile attempt to control something that was never under our control. To ignore 3i Atlas would be like closing our eyes to the abyss. Scientifically, it would mean missing a unique opportunity to revise our models of interstellar body formation. If the absence of water and the exclusive presence of CO2, if these facts are not explained, how confident can we be in our theories about the origin of the Earth, the Moon, and even life itself? How many future discoveries might be misinterpreted because we're stuck in outdated models? To neglect this topic would be to repeat the mistakes of the past, when inconvenient data was buried until new generations were brave enough to dig it up. But the consequences go beyond science. On a human level, 3i Atlas confronts us with a vulnerability we prefer to ignore. We live our daily lives as if space is a distant stage. But the truth is, a body tens of kilometers wide flying past us is a harsh reminder that the universe offers us no guarantees. We continue to invest in wars, petty political squabbles, and pointless power struggles, while the cosmic reality exposes us to risks far beyond our control. Ask yourself, what would it say about our civilization if humanity was remembered as the species that ignored the clearest signs from the heavens? On a civilizational level, 3i Atlas is a test of maturity. We have a chance to face this phenomenon as a united species, bringing together science, politics, and culture to seriously investigate the mystery. Or we can go down the path of denial and simplification, preferring the comfort of shallow narratives. The price of that choice will be paid sooner or later, because whether it's natural or not, 3i Atlas has already shown that reality is more complex than we imagined. And in the face of that complexity, there is no safe space for indifference. Think about how many times in your life you've encountered something that didn't make sense, but you chose to ignore it so as not to shake the foundations of your beliefs. How many times have you ignored the signs because they demanded a change you weren't ready for? 3i. Atlas is the cosmic version of that dilemma. It's offering us a choice between the illusion of security and the courage to face the abyss. At the same time, we have to admit, understanding this object could be as transformative as it is painful. If we accept that probability doesn't explain its existence, we'll have to rewrite entire theories about interstellar space. If we confirm that its trajectory is not random, we'll be facing an event that will change our conception of the universe. Even if we discover that 3i Atlas is just an exotic, natural body, it will still be a discovery capable of redefining our boundaries. Either way, discomfort is inevitable, and that's what drives us forward. This is the moment when the tension turns into responsibility. The silence around the James Webb can't last forever. The data will come out, and when it does, we'll have to decide how to interpret it. With the same intellectual laziness that reduced Oumuamua to a one-time curiosity, or with the seriousness this moment demands, realizing that we have a unique opportunity to expand our collective consciousness. This is the crossroads where we stand. And perhaps the hardest lesson is this: the universe isn't waiting for us. 3i Atlas is following its own path, indifferent to our debates. It doesn't need to be understood to exist. It doesn't need our explanations to follow its course. The choice to learn or to ignore is entirely ours. In judging the unknown, we are ultimately judging our own readiness to face the truth. And now, look inside yourself. How do you deal with discomfort? Do you prefer to push it away or use it as fuel for growth? That's the same question humanity is facing with 3i Atlas. This question also determines whether we will remain a species that avoids discomfort or whether we can openly face what it means to live in a universe this vast. That's why, now more than ever, we need to broaden this conversation. This isn't a topic for isolated experts in labs. This is a dialogue that needs to cross borders, that needs to reach you, me, everyone who has the courage to confront the unknown. So if this video has stirred something in you, if it has lit that spark of discomfort that comes before every awakening, subscribe to the channel, hit the like button, and write in the comments what this mystery makes you feel. Every voice that joins in amplifies the collective search for answers that won't come ready-made, but will only exist if we find the courage to keep asking. And remember, the greatest danger isn't what the universe is hiding from us, but what we choose not to see.